Cool. So, yeah, databases is our first topic. There's plenty of other fascinating things to come. But yeah, as we discussed the other day, databases are behind most of the cool things that you can do on the internet and elsewhere. A computer by itself is a bit pointless. Do you remember from F451 we've got input, output, process, storage. Storage is a big part of your data processing. Being able to find the data you need quickly and easily and efficiently is extremely useful. So that's why we have databases, and most of the best websites that you use most often, they have a database behind them. So we looked at, you could store your data in a list, which is great. It's simple. But, and what do we call this? What do we call just a list of all our data? Who was taking notes? Flat file, excellent. Great, yeah, flat file. That's what we call it. Which is great because it's nice and simple, and when we don't have much data, and if it's just us accessing it, then that's fine, that's no problem. But what are the problems? There are a few problems with a flat file when things grow.
Sorry, I'm late.
You are? Find a seat. We'll talk later. Yeah, there are some problems with a flat file and storing everything in a flat file database. What are those? Do you remember? Any ideas? Yeah? Yeah, so only one user can edit it at once, which is not great.
It's not secure because there's like no restrictions on it.
Yes, not secure. There's no restrictions on it. You don't have to enter a username or password. If you can access the file, you can access everything in the file. Yeah? Yes, absolutely. So if you want to find something in your file, well, it's fine when it's small, but the bigger the file becomes, the longer it takes to search through your file looking for stuff. And don't even think about trying to sort the data. And when you add things, do you add it in order? Do you add it at the end? So, yeah?
It can be quite easily duplicated if there's just one.
Yeah, you can. I suppose you can make a duplicate of your file, relatively easy. But yeah, so the other thing about this searching and sorting your data is that if it's just in a text file, does anyone want to finish my sentence? If you've got all your data just in like a text file, a plain text file, then you have to write the code yourself. Like you did when you were doing the hangman things or noughts and crosses, or when you were writing your own programs, you were storing information in a text file. You have to, write the ways of entering the data and removing the data yourself. With a database, that's all there for you. I say database, what do I really mean? There's a word that comes before database, because this is technically a type of database. It's a place to store data. Yeah? Relational database. Good. So this is the alternative. This is new and improved. So rather than just having one giant list, we split our data into lots of little lists, and we have links between them, like this. So rather than, so if we want to change physics, for example, if we want to change the room that physics is in, we just change it once, rather than having to go through each individual student and change it umpteen times. And so there's no duplication of the data. We've only got the time and the place of physics in there once. So if we change the place and the time, we only have to change it once. So there's no duplication of data, which obviously makes our database smaller. Yeah, saves quite a bit of space. There's also no inconsistency, because these two don't disagree with each other, because there's only one of them. If that makes sense. Yeah, and it's much easier to add data and easier to control data if you use a database management system. A database management system is like a system that implements a relational database. Yeah, so I'm trying to think of an analogy. The one I used last time was like Java is like a programming language, but NetBeans is like an implementation of Java. So it's like a Java management system. So you can have a relational database, that's just a theory, just a theoretical concept. Your database management system is a thing that actually lets you use a relational database. And it controls everything, controls your data organization, has tools for logging in and creating new usernames and passwords and security and stuff. Allows you to store and retrieve your data through the database management system. You don't have to write your own routines for doing this. They're already there. And it also controls the integrity, the correctness of the data. Um, yeah, we'll come back to this integrity in a minute, I think. So yeah, but at a base level, it just takes inputs and gives outputs. If you have to draw a very simple model of a database, you've got a database in the middle, you've got inputs coming in and outputs going out. And storage happens in the middle. It's a complete system for storing things. That's what your database management system does. Cool. So these are some words that you might have seen before. These are some examples of a database management system. Access is a database management system. Oracle is a database management system. Has anyone heard of Oracle before?
Yeah.
Where have you heard of Oracle? You just heard the name.
Java.
Oracle, yeah. So Oracle is a very big company that only does databases, or only did databases. And they do big, powerful database management systems that are used by banks and insurance companies and people who have large amounts of money but really can't afford to lose their data. So that's where Oracle gets most of its money from. They've made so much money that Oracle started out only making the database software, the database management systems. But Oracle stuff tended to run on the hardware built by Sun Microsystems. Sun Microsystems made the Solaris platform and makes the Sun Spark hardware, which is probably not that interesting. But as a side shoot, one of the other things that Sun did is they made Java. They developed Java. And because banks also use a lot of Java. They write their stuff in Java, which is part of the reason it still exists. And yeah, so Oracle got very big and bought Sun Microsystems. So yes, so Oracle owns Sun Microsystems, and therefore they also own Java. They also own OpenOffice. If you've installed OpenOffice, you've probably seen the Oracle logo on that now. Never used to be there, and then Oracle bought them and went, we can put our logo on that, so they did. Before that, if you installed an old version of OpenOffice, it says Sun Microsystems. That's by the by, but Oracle is a very, very big company. You don't see them, you're unlikely to have any Oracle, well, you won't have the Oracle database software installed on your home computer. But if you go and work for a bank or an insurance company, chances are you're going to have to deal with Oracle database management systems, which is fine because they just do this. They just do what we're talking about. They take data and they give it to you. They sort of take it, store it, and input, output, and that's basically it. That's all they do. Yeah, so here's some new words. Entity, attributes, primary key, secondary key, and tuple.
Will we be given definitions from?
If I'm in a good mood. Yes, I'll define these words for you. So maybe just don't write them down just yet, or write them down and you can write your own definitions in a minute. But so there is a table from our database. It's not, I mean, it's only, this information is only about students, as you probably noticed. This table, this is one table, and we might have other tables that I haven't shown you yet. I'll show you some more later. So this is one table within our database. You remember we were talking about how a relational database is lots of lists, lots of little lists all sort of linked together. Here's one of those many lists. There will probably be others that are sort of linked to it. It'll make more sense in a minute when we move on. But so this is a table of data. This is actually an entity. When you hear entity, when you see the word entity, you can just think table. It's a table of data. Okay? So this is a table of data, also known as an entity. Attributes are these columns within the entity. So when you see the word entity, you just think table. If you see the word attribute, think column. Or at least I tend to think column. You can think, depends on how you normally draw your things. I normally divide them into columns. You could equally divide them into rows, and then yeah. But think column for now. That's what we've got there. I won't overcomplicate it. So yeah, attributes are columns. Yeah. The primary key is an attribute of an entity, but it's a special attribute of an entity. What makes that special? what it's ordered by, yes. Good observation. That's not necessarily... I could reorder that and it would still be the primary key. Why is the primary key special? Why do you have a student number? What's the purpose of you having a student number, do you think? Yeah?
If you were to search by student number, it would come with all the information under that student number, whereas if you were to search by name, you could have like 10 people called Helen.
Yes, exactly. So there may well be other people called Helen, or there may be other people with the surname Jones. In fact, you might have two people who live at the same address and therefore share the same phone number. Occasionally you see people using the email as a primary key, but mostly I think we'll stick to the idea that your student number is your primary key. It is the unique identifier. It uniquely identifies every student in the college. Yeah?
So what should I write down as a definition?
Just, okay, I'll come to that in a minute. You can write down a unique identifier, but I'll give that in a minute. Maybe just let it wash over you to start with. So student number is the primary key. The student number is an attribute, which is the primary key. The primary key is a special attribute which uniquely identifies every tuple. Actually, I'll start using that word now. So a tuple is a row. If an attribute is a column, then a tuple is a row. So this is one tuple, and Sally is another tuple, and Emmett is another tuple, and Reginald is a fourth tuple. It's an annoying thing about computing, but computing is actually quite simple. It's just some of the words sound complicated. But they're not really. If they used the word column instead of attribute, then life would be much easier, but they don't. So everyone thinks it's complicated. It's not really. If I said row instead of tuple, then everyone would be happy, but no. Never mind. Yeah, so we've got entity, we've got attributes, we've got primary key. We know what tuples are, and a secondary key is... So student number is great, because student number uniquely identifies every student in the college. Problem is, I struggle to remember your names, let alone your student numbers. So, but there's a good chance I'm going to be able to remember your names. I'm going to be able to remember an individual name. So I'm probably going to be doing more searches based on your surname than I am based on your student number. So surname is a secondary key. It's something that I will also be searching using. So an entity is a thing about which you need to store data. That's the exam definition. So however you've been writing your definitions, I strongly recommend you add that to it. And now we get to the definitions that you were asking for. But yeah, so an entity is a thing about which you need to store data. That's what the examiners call it. Think table, but write a thing about which you need to store data. An attribute. Attributes are properties of an entity, or an attribute is a property of an entity. Or column. Think column, but write properties of an entity and score marks. If you write column, you probably won't get marks, though you'll understand it. The primary key is a unique identifier. It's also used to relate the entities. Maybe you write that down now, and I'll explain in a bit more detail about why that exists in a minute. So a primary key is a unique identifier. Uniquely identifies a tuple. That would be actually a better thing to write in an exam. Explain the purpose of a primary key. The primary key uniquely identifies a tuple, and then you clearly know what you're talking about and are well worth the marks. And it's used to relate entities. A secondary key is indexed to allow for faster searching. That just basically means that the database recognizes that you're probably going to be searching using this quite a lot, so it holds it all usually quite close to main memory. Or it's the algorithms are optimized in a way that if you search by surname, I'm more likely to search by surname than I am by telephone number. So the database is optimized to, it's indexed to allow me to search by surname. If I want to search by telephone number, it will probably take a bit longer because it's not optimized to do that. It hasn't been indexed. Has anyone come across indexing in other areas? Where else have you seen indexing?
Sequential factors.
Yes, good. That wasn't what I had in mind, but yeah. So index, but for a similar reason. If you have a sequential file which is indexed, it's easier to find the information that you need. Windows 7 has a feature of indexing all the files on your hard drive, which means that when you do a search, it's faster to find your files. Problem is, it means that every now and again it has to update the index. So every now and again, you'll see your computer's hard drive light is on, even though it's not doing anything, and it's busy, and that's because it's updating its index. You can switch that off, and you should do if you've got. It's one of the things you have to do to your computer if you install a solid-state hard drive. Sorry, I've just gone geeky for a moment. I'll come back later. But yeah, so a secondary key is indexed to allow for faster searching, and there's loads of stuff on indexing. If you want to know more about what the word indexing means, then that's a little bit more detail. If you're not bothered, then it just means optimized for searching. So that's it. That's a significant chunk of what you need to know to answer. Yeah, there's a good like 10 marks or so. I should probably have brought down a past paper actually, because these questions are asked on past papers. Things like, what's the purpose of an entity, and describe here's an example of an entity. Pick out 4 attributes, and things. Any questions about any of this? Okay. Of tuple. A tuple is a row. I haven't actually seen a question on any of the past papers saying define the term tuple, so I don't have a specific exam-land definition of it. But a tuple, you could say, is an instance of an entity. Instance, I think, is probably a good word to use there, because yeah, each of these, like Emmett is an instance of the student entity, and Helen is an instance of the student entity. Or use the word row as well. Just
Call it a record.
yeah, a record actually, that would be a good one. A record from the database. An instance of the entity, an instance of a record within the database. Yeah, that would be a good thing to write. A record. Cool. Good question. Any other questions? So, here's another example, entirely separate, but so can you point out the entities here? I should probably, yeah. Well, does anyone want to, who thinks they can point out an entity from this table? Yes?
Booking.
Booking, excellent. Booking is definitely one of the entities. Someone else? Amy? Pitch, yes, pitch is an entity. Anyone else? Do you want to have a go? Pitch fee, great. These are really the only entities that we have in detail. Yeah, so there they are. So if booking is the entity we're looking at, which attribute is the primary key? Booking reference, good. Yeah, so booking reference uniquely identifies every row, every tuple in this entity. Great. What about in pitch? What's the primary key in pitch? The chap in the, yeah, pitch name? Pitch number. Yeah, pitch number. Absolutely right. So pitch number is the unique identifier for each tuple here. And what about in the pitch fee entity? I have to get, what's your name? Ollie. Splendid. What's the unique identifier? What's the primary key for pitch fee? Pitch type. Absolutely right. Spot on. Cool. Yes. So these are the entities, and those are the primary keys. Interesting point, though. Let me go back a bit and free up some space. Pitch number is the unique identifier here in pitch entity. It also appears somewhere else, doesn't it? Where else does it appear? Where else do you see pitch number? It's up here, isn't it? It's also in the booking reference. It's the second attribute of the booking entity. Yeah. So I wonder. We'll come back to why it's there. It's not unique here, though, is it? Because we've got pitch number 42 is in there twice. What's going on there? Why did we do that? Does anyone want to try and explain why that might be happening? Yeah.
Not being unique, because they've got a pitch type and a pitch fee, and that's secondary to pitch, and that there's loads of ones and twos, and on the booking entity as well. There's 2 42s, 43.
Yes, it's a good observation, though it's not quite what I was getting at. You remember earlier on, we had there were two things that we were saying about the primary key. So the primary key is a unique identifier for every tuple. What was the other thing you wrote down? Alex? Yes?
Even though they've both got the same pitch number, they've got two different customer numbers, so they're two different records. And when you search it by the book reference, you see them as two different records.
Yes? Yeah, you're absolutely right. No one's really said I think you were sort of hinting at it, Alex. So yeah, you wrote down a primary key is a unique identifier for each tuple. It's used to relate entities. That's exactly what's going on here. It's used to relate these different entities. So say for example, I do a search on booking reference 317. So I type booking reference 317, and from that I know that it was pitch 42 on week number 17, and customer number, the customer that booked it was customer number 517. But I can get more information than that because I know that pitch number 42 is of pitch type 1. And because I know it's of pitch type 1, I know that it costs £6. And I might know there might be some more information in pitch. So it might say pitch type 1, might say where it is, might say what type of surface it is, and all sorts of other details. So I can use it to link my entities. It's the relationship between my entities. The primary key pitch number in pitch is a foreign key in booking. If I find my clicker, I'll get the word foreign key up so you can write it down, but it's spelled as you'd expect. So pitch number is a primary key when it appears in pitch, but a foreign key when it appears in booking. Similarly, pitch type is the primary key in pitch fee, but is a foreign key when it appears in pitch. A foreign key is used to relate entities. A primary key of, I should probably have written that down actually, I didn't, but it's the primary key of one entity when it appears in another entity. Used to relate. Used to relate entities. Yeah, the primary key of one entity when it appears in another. I'm not going to finish writing that down, the pen's a bit odd, but yeah. Used to relate entities, it's the primary key of one entity when it appears in another entity. Because it is a primary key, but when it appears in another entity, where it isn't the primary key, it's a foreign key. And the reason it's there is to relate the entities. Does that make sense? Bit odd, but once you grasp it, it actually makes perfect sense. We've got all these lists. The whole point of a relational database is that we had our colossal database, and we had our colossal flat file, and what we've done is we've broken our colossal flat file, our colossal list, into a series of small lists. Each list is called an entity, and we use primary keys and foreign keys to relate these different lists. So we can pull out one just by finding, by doing a search for booking reference 317, we can find a lot of information from all these different entities because they're all related. Does that make sense? Good. I'll get you to do a little exercise on that in a minute. Before I do though, this is quite messy, as you can see. I've got arrows all over the place, and if I draw more arrows putting on the relationships, it can quickly get quite difficult. That's why we have such a thing as an entity relationship diagram. Take note, because when you do your project, you will probably have to draw an entity relationship diagram. When you're doing your projects, you're going to be probably storing some data. When you store your data, draw an entity relationship diagram saying how you store your data and score more marks for your project. And an entity relationship diagram works like this. So we have, first thing you do is you draw out all your entities, you put them in boxes. And then what you do is you decide on what the relationships between them are. So the relationship between pitch and booking might be a good place to start. So we've got booking up here and we've got pitches down here. So pitch number appears in booking reference many times. So pitch number only appears in pitch once, but it appears in booking many times. We have a one to many relationship. That's why this blue line here is sort of only has one thing on the left, but has three things on the right. That's how you draw the relationship between pitch and booking. It's a one-to-many relationship. This line literally means one-to-many. So the relationship between pitch and booking is known as a one-to-many relationship, because pitch number appears in pitch once, but appears in booking reference many times. So it is a one-to-many relationship because it is that way round. So with that in mind, who wants to try and tell me the relationship between pitch fee and pitch? What's the relationship between pitch fee and pitch? So which end is the many relationship and which end is the one relationship? They're related, so I'll draw a line.
The one is the one is pitch fee.
Yes.
Pitch.
Good. So the one is pitch fee and the many is pitch. Spot on. Does that make sense? Do you all see why it's that way around? It's very easy to get them the other way around. It's very easy to get these things muddled up. Don't get them muddled up because you'll lose marks. Ironically, actually, when these questions appear on the exam, it's often worth 3 marks. When it says, like, draw the relationship between, on this entity relationship diagram, there's 3 marks. There's one for just drawing a line, and then there's one for getting each end right. But you can easily lose 2 marks if you get the ends the wrong way around. So don't make the mistake. I'm happy that you didn't. Pitch type appears in pitch fee once, so the pitch fee end is 1, and it appears in pitch many times, so pitch is the many end. And yeah, customer is something that I haven't put the table on there, but you can imagine that one customer, so over here you'll have some customer details, you'll have another entity which has all the details of the customer name, customer contact details, possibly their credit card details as well. That will all be stored in a separate, hopefully extremely secure entity. But one customer will make many bookings. So it'll be one customer making many bookings, so that's why it's that way around. Yes? Cool. So, here's an exercise for you. You've been sitting listening to me waffle for long enough. I want you to, either on a piece of paper or on a computer, I'd like you to create these entities, create the entities lecturer, student, and subjects, and define some entities for them. Define at least 5 attributes for each of these entities, if you would. And we'll see what you come up with. This sums up the entities. We've got some different entities, and we've got some. We then drew an entity relationship diagram here. So you've been trying to do the same thing, but for lecturer and student and subject, and defining the primary and foreign keys. And if you do that, then you win a car, though it'll take a while for you to earn it. So these are, I don't know, my definitions. So you've got, there's lots of things you can store for lecturer. I've only got lecturer ID, first name and surname, but you could have home address and maybe age and maybe experience and maybe links to various other places. And with students, you can have student ID, first name, surname, and all the other details of the student, age, address, telephone number, email address, and whatnot. And similarly with the subject, you can have subject ID and room, like what room it's taught in and how long it happens and what exam board it's with and stuff. But then you run into a problem when you have these different. How do you do the relationship between lecturer ID? Because I'm a lecturer and I teach 3 different subjects, and each student is doing several different subjects as well. And each subject, I mean, what do you do with the subject? So what you could do is you could just have. You can have a small list in here, so you can have subjects. You can have like computing AS and computing A2 and computing HND all in that one box. But as you say, when you come to searching and sorting, that'd be very difficult, wouldn't it? Because would you try and match the entire string or just one word of the string? Suddenly it becomes quite tricky. And I suppose you could have subject 1 and subject 2 and subject 3. You could have like 3 separate columns.
Then certain students may be doing more studies than the other.
Precisely. So some of them would be blank, and some of them you might have inevitably you don't have enough how many is enough? How many is too many? Yeah, this is not the ideal solution. So what you could do is you could say, so this is basically as far as we've got. So we've got lecturer, and we've got subject, and we've got student. We know they're related somehow, but I mean, they basically end up being many-to-many relationships. Because is this going to work? Almost, yeah. So we have here some many-to-many relationships, which are not great. Yes, whiteboard needs recalibrating, and you can do it later if you'd like. So yeah, we want many-to-many relationships, and that's a problem, as we've already decided. It makes it a pain to search, a pain to index, and how many fields do you really need? And there isn't really a nice, neat solution to this. Or is there? What you can do, I'm going to get rid of that layer now, which is actually quite handy because we're going to update it. We're going to improve on our database design. And now my clicker doesn't work. No. Aha, I've mended it. So, scrap those end attributes. We don't need them. We're going to find another way of relating them. We're going to create entirely new entities. So here we've got an entity called student subject, and student ID and course and subject ID. So student ID. So who's this? So this is Amy is studying maths, and Amy is also studying physics. And then so you can have plenty of others, and that neatly solves the problem. Similarly, we can do the same thing for lecturer. So lecturer ID. So we can create an entirely new entity. And then lecturer ID and subject ID, and that all works perfectly well. And that neatly solves the problem, doesn't it? There's one slight hiccup. There's one more slight thing that we need to overcome. So, I mean, this neatly solves the problem of how many extra columns do we need? Well, we just add as many extra rows in student subject. If a student decides to take one more subject, we just add another row. And if a student drops a subject, you just delete a row. And if you want to search for all the students, subjects a student is taking, then you just sort of search by student ID, and you get many results. So how does that go against what I've just been saying? What's a primary key? Look at your notes. What have we decided a primary key was? What do we agree that a primary key is? It's a unique identifier, isn't it? So what's the primary key in student subject? It doesn't have one. There is no one attribute that uniquely identifies. There's no one attribute that uniquely identifies anything there. In this case, we need to use what's called a composite primary key. What do you think that might be?
A primary key that's composite.
A primary key that's composite. A primary key that's made up of two attributes. In this case, the primary key is a composite primary key made up of student ID and subject ID. Those two things together uniquely identify every tuple in that entity. Does that make sense? Not that I've come across. To all intents and purposes, no. You don't have composite foreign keys because that it's the primary key that uniquely identifies this. You wouldn't then find student ID and subject ID together in a different entity. No, you won't. Not that no, you wouldn't. There'd be no point. And then similarly, you do the same thing for lecturer subjects. So each tuple, or each, so you can have other information in there if you like, but basically lecturer ID and subject ID together form the composite primary key. You write that down. You need to know what a composite primary key is. A composite primary key is made up of two or more attributes to uniquely identify a tuple in an entity. Should I say that again or write that down? So this is arguably way more than you need to know about how and why many-to-many relationships exist and what to do when you see them. Just to sort of summarize, I suppose, it might be easier. Got a bit too far back. Right. So, third normal form. There is a second normal form and a first normal form, and you don't really need to know what they are, you just need to know what third normal form is. A database is in third normal form if it has no many-to-many relationships. Yeah, so I just skipped and introduced this new idea of third normal form, because the databases that you've drawn, they can have many-to-many relationships and it can still be a database. And like I say, you can just cram all that information into one cell, or have several cells that say things like student 1, student 2, student 3, student 4, or subject 1, 2, 3, 4. Okay, I was wondering where that came from. So yeah, you can still have databases that are not in third normal form, but it's not good. Those databases don't work very well, difficult to search and sort. So yeah, so there's so no many-to-many relationships. If you see a question that says why is this database not in third normal form, the answer is always because it has many-to-many relationships. Many-to-many relationships are bad because it means it's not in third normal form. Does that make sense? You might like to write that down, or hopefully it makes a little bit of sense. I don't want to go into masses of detail about first and second normal form because, to be quite honest, you don't have to know either for the exam or, well, life in general. But you will see a question which says, why is this a problem? What's wrong with this diagram? Or something, in which case you say, it has many-to-many relationships, so it's not in third normal form. If you want to be really posh, you can use this phrase non-key functional dependencies, which is a more complicated way of saying many-to-many relationships. Non-key functional dependencies are bad. We want none of them. Yes, so you can write that down and remember it, and it may well score you an extra mark. But in general, if that's way over your head, and you just remember third normal form means no many-to-many relationships. If there's a many-to-many relationship, it's not in third normal form. I think I've said that plenty of times. So when you're drawing your entity relationship diagrams, they'll look a bit like this. So you can have student and subject. That's a many-to-many relationship, which means it's not third normal form. Thank you. Which is bad. It has non-key functional dependencies. Second normal form. Long story short. So what you do, yes? If you really want to study database theory in mountainous detail, there's actually about 6 normal forms, and then there's like Bernoulli normal form and Erlang normal form, and there's like many different types of normal form, and every now and again someone comes up with a new type of form and then gives it a name and forces people to study it. I don't really recommend it. So student subject many-to-many relationship is bad. So how do we solve this problem? You create a new.
So you do a subject dash.
Yes, you create a new entity.
Call it subject.
And call it student dash subject. Give it a composite primary key, which is made up of
two or more.
Yeah, made up of 2 or more attributes. Usually the primary key from here and the primary key from here, you sort of combine them together, you glue them together into student subject. That becomes your composite primary key. If everything I've said since making those things appear just made you go there, the only thing you need to know is what's on the screen. This is the sort of base level of what you need to know. If you understand it at a slightly higher level, there's an outside chance you can pick up a few more marks on databasey questions, especially if they're like 8 markers. But this, if it's just for simple, what is third normal form? You say third normal form is a database that doesn't have any many-to-many relationships. Just remember that. If most of it's over your head, just remember third normal form equals no many-to-manys. And this is how you break them. That's it. So if you see a diagram that looks like that, scribble it out and underneath write this and you'll score marks. And they do that a lot. They do it every year. It's a common question. And it's usually worth at least 3 marks. Because you get 1 mark for drawing student subject, and you get 1 mark for each of these, and getting the things the right way around. Yeah, you'll notice, please take note that you're sort of swapping the ends as well. So here it's many-to-many relationship. Here it's one-to-many and then many-to-one. You don't just sort of draw a little box in the middle. You draw a little box in the middle and you swap the feet round. They look like crow's feet. The relationships round might be a better way of saying it. Happy? Any questions? Is anyone looking at that thinking, I think I'm going to do English now? No? Okay. Oh, then that's good for you. Instead of computing, perhaps. If you can cope with this, then there isn't really anything much more complicated than this on the syllabus. He lied. No, to be fair, actually, if you got everything that I've been talking about, and the reason why many-to-many relationships are bad, and where they come from, then you're doing well. And if that was way over your head, then just remember what's on the screen, and you'll be fine. Cool. That is most of the databases topic done.